So now we will find out the diameter of bright and dark fringe. For that purpose, I have to imagine some kind of geometry around this lens. So here's I have so this is my lens. This is my lens, and I am imagining some kind of sphere around it, which is having the center C, and my lens, this is the point Q of my lens, and this is the point P of my lens, and the sphere which I've imagined is having some radius R, and I am trying to find out the diameter of any nth fringe. That nth fringe is here having some P sub nth thickness. So this is the radius. So this is having some, so this r, small r, is the radius of my fringe which I have considered. So the distance from this point to the center will also be capital R. Okay, the distance from my fringe to the center will also be capital R, and this thing point I am calling it as small, I'm calling it as n. So the thickness, if this is the thickness T, means the distance from here to there, it is also T sub n. So the distance from N to C is R minus T, is the distance from N to C. So from triangle, this point I have to give some name for this. I'm calling it as S. From triangle NSC, R square is equals to R minus T whole square plus R square. Now this R square is equals to R square plus T square minus 2RT plus R square. This R square will get cancelled out. R square is equals to 2RT minus T square. Here you see this radius is very much bigger, very much larger than the thickness. So the R is so greater than T. So that's how we can ignore this T square. So we will be remaining with T is equals to R square by 2 capital R. So this is the thickness. So here this one is T sub n, T sub n, T sub n, T sub n. Okay. So now I'm calling this as my equation 5. So to find out the diameter of dark and bright fringe, after getting the thickness, we have to substitute that thickness in this equation. Del is equals to 2 times of mu is equals to 1, then T sub n is equals to R square by 2 capital R minus lambda by 2. This 2 will get cancelled out. The path difference is equals to R square by capital R minus lambda by 2. So initially we had the equation, the path difference equation in terms of the thickness T, but now you have the path at what particular radius you can get the constructive interference or destructive interference. We can find out. It means that at what particular diameter we can find out the constructive or destructive interference, because we got the path difference in terms of the radius. So for to find out the diameter of bright fringe, we have to take the path difference of the bright fringe. For the bright fringe, the path difference should be n lambda. If you want to find out the at what particular diameter you will get a bright fringe, what you have to do, you have to equate this path difference with this. So it will be r square by r minus lambda by 2 is equals to n lambda. So r square by r is equals to n lambda plus lambda by 2 is equals to r square r 2n plus 1 lambda by 2. R is equals to d by 2, so it will be d square is equals to 4r 2n plus 1 lambda by 2, it will be lambda. So this is the diameter of nth bright fringe. Why? Because we have taken the condition for the bright fringe. Similarly, we can find out for the dark fringe. So this is the diameter of the bright fringe. You see, so the diameter of fringe will depend on the order of fringe. Yes, it is obvious. If you are talking about the first fringe, it will be having a less diameter. If you talk about the third fringe, it will be having more radius. So how the diameter and the order of the fringe are related, this is how they are related. The diameter is proportional to under root of n plus 1. Now we will find out the diameter of nth dark fringe. For that purpose, we have to take the path difference of dark fringe, that is the path difference will be equal to 2n minus 1 lambda by 2. This is the path difference for getting destructive interference. So because of that, why we are taking destructive interference condition? Because we want to find out the diameter of dark fringe. So now we will equate this path difference with this one, so that we can get the diameter of the dark fringe. So it will be r square by capital R minus lambda by 2 is equals to n lambda minus lambda by 2. These two things will get cancelled out. We will be remaining with small r is equals to capital R n lambda. The diameter d square is equals to 4 r n lambda. So it will be d is equals to 2 under root r n lambda. So the relation of diameter with the order of dark fringe is d is directly proportional to under root n. So you see, the diameter relation for the bright fringe and for the dark fringe are not same. They are not following any linear relations. So because of that, after seeing this expression, we can say that the fringe widths won't be same, won't be constant for the dark and bright. As you go away from or near to it, the fringe width will change because the diameter is showing different relation. That's how we can say that the. So now we will find out the fringe width beta. What is fringe width? The successive distance between two bright or dark fringes. So here's I have so this is the first bright I have to measure the distance. It means I have to find out r sub 1, then I have to find out r sub 2. What I have to do to find out the fringe width beta? So this is the fringe width beta. What I have to do for finding the fringe width beta, I have to subtract r2 with r1, or the general equation for that will be r sub n plus 1 minus r sub n will give you the expression for the fringe width beta. So this is how you can find out the fringe width beta. So this was all about Newton's ring. In the next class we will be discussing some application of Newton's ring. With the help of Newton's ring we can find out the refractive index of different materials, and with the help of this experiment we can also find out what is the wavelength of the monochromatic light source. There are so many applications of Newton's ring. So we will be discussing one by one all the application of Newton's ring in the next video. So till then, stay tuned. Bye. Thank you so much for watching.